I don't suppose anyone can tell me what's happened to my terminal here. No? All right, we won't worry about it.
We took the lecture notes out like on Wednesday because I have so many assignments in between. Is it possible to like if you can make changes to email us like a link before so we print out because there's some information on the lectures and
They should be all up now for the entire course.
yeah, what I mean is like I printed them out, but the different to lecture notes that you have today because you must have made a minute.
No, we were just finishing last week's.
Oh, that's last
Yes, it was the end of week 1 part 2.
make amendments to the lecture notes.
No,
last week. I didn't bring
it was just the end of them. That's all.
Got it.
Yes.
Thank
Yep.
you.
No worries. Okay, we're back. Are we back? We're back. Someone said lecture part 2 before GTA 6. So true. All right. Something's gone wrong. So the room seemed to have lost internet, and that's really bad when you're trying to stream. Okay, what were we doing? So we were going to do a little control flow demo. So let's do my favorite bouncer program. So and we'll use a few of the concepts, in fact, maybe all of the concepts we've covered so far. So I'm going to slow this demo down so you can follow along, but I can't go too slow, so it's all a balancing act. So let's make a constant for the minimum age that we're going to let people into our club. Maybe this is an American venue. So this is a constant. How do I know it's a constant? It's using the hash define. It's above the main function. Something else worth noting here is we don't have semicolons at the end of constants. That will cause problems. It's something that gets me all the time, actually. All right. So this is a program. Someone comes along. They want to enter our fine establishment. What do we need to know about the person? Their age. So how do I find that in? We're going to use our variables and scanning. So I might make a variable called age. What do I assign it? Yeah, nothing. Let's scan something in. So how do I scan F? Tell me what to type, someone. Scan F. Now what? Now be really literal. Brackets. I'm scanning in an integer because an age is a whole value. So I have my format string there, %d. Why %d? I'm scanning in a decimal integer. What am I scanning it into? Ampersand age into age, semicolon. Now, if I ran this program, in fact, let's run it. So that's compiled it. Let's run it. Did I do something wrong? Nothing wrong? But this doesn't look very useful. My bouncers, it's a really busy nightclub or whatever. My bouncers are going to go, what? What do I do here? Yeah, we didn't prompt. So right now it's waiting for input, but it's just not clear what's happening. So pretty much anytime we do a scanf, what do we want to do before? Printf, and we want to ask for the value that we're asking for. Please enter your age. Well, not your age. Something like that. Yep. Then it'll prompt on the scanf, and then it'll make a bit more sense. So let's quit that. Control C. Oh, what is going on here with everything? Oh, what? Oh. Anyone know how to fix this, Angela? Have you seen this before? My VLab is like the resolution. Oh, okay, we're back. I don't know. I think because the monitor's disconnected. That's the wrong program. All right, please enter the person's age. I can enter, 43, and then the program ends. So, and so something worth pointing out when we're starting to write bigger programs, really, really important. Please write this down, get it tattooed somewhere on your body. Compile frequently, okay? I can tell you firsthand, I do this myself, I forget to do it all the time. I write 1,000 lines of code, and I realize something went wrong in the first few minutes, and now it's impossible to debug because there's so much code there. Whereas if I had a little typo now, I would have detected it, and I would have been able to progress. Does that make sense? Compile frequently, and save frequently too as well. All right, so we're reading an age in. We've got this minimum age. Now, depending on the age that's entered, we want to print out one of two messages. So what tool can we reach for now? The if statement. Okay, the if statement. So what do we want to do first? It's a valid age or not a valid age? Let's do valid first. So how do we do it? If, brackets. What's the question that we're asking here? Well, we're doing the valid case first. So they've got to be older than 21. What if they are 21? Typically, that's fine, right? So what's the operator that we want to use? Greater than or equal to. Excellent. Now, should I type 21 here? I should use the minimum age. Why? Why is it important to use constants here? There's no difference. The program will do the exact same thing. Yeah, so the reason we do this is because if I want to change the minimum age, and I've used it in multiple places, I just have to change one constant. So let's use the minimum age. All right. If age is greater than or equal to minimum age, which is 21, then what do we want to do? Yeah, we can print out some message. Someone tell me a message. Congrats. You're in. Oh, Angela, they think 21 is old. All right, should we run this? Who's following along? It's going well? All right, give me an age. Give me an age. 12? What do we think's going to happen? Nothing happens. The program ends. Give me another age. 7. We're going to just do all the numbers below 21 until we go home. Oh, 70, sorry. Anyway, sure, I'll do it. Okay, cool. So depending on the value, the program is doing different things. So we're controlling the flow of the program.
Is it possible to have like multiple conditions in one?
We'll talk about multiple conditions in a moment. We'll talk about else statements in a moment. Say that again. Const. We don't use it in this course. We use hash defines. There's a reason for it, which I'm struggling to remember, team. Why don't we use const? Tim? Angela?
I think there's a very slight difference in how constant hash defines are like.
Yeah, constants are put on the stack, I think, and it doesn't there's no benefit over a hash define, whereas hash defines do have benefits over a variable. So it's a little bit of a technical answer, but constants, I think the answer is they don't use any less memory than a variable. when I say const, I mean const. It's something we haven't covered yet. I'm just answering this question in particular. Whereas hash defines give us a benefit in that they're more efficient. Whereas consts don't give us as much of that benefit. All right. Who wanted to know about else statements? Yay, it's your lucky day. All right. If you look back to this example, in the case where they're younger than 21, we have no way to give them a message. Does that make sense? So you might be then thinking, well, Jake, you fool, why don't you just put a message here? Is anyone thinking this? What's the problem with this? It's going to print it even if they are old enough. We're missing something here, something quite important. Ah, that's a good question. Let's talk about else first and then get back to it. Yeah. Okay, so we're missing something. And in all their wisdom, the C designers gave us the else statement. So the else statement is super simple. It must be associated with an if statement, and it just gives us the block in the else case. And it only runs if the first condition evaluates to false. So here's what the syntax looks like. I can't tell if people are distracted or it's too. We'll do a poll in a second. So here's my if statement, right? There's the block that runs. But in the case that the if statement was false, here's the other block that runs. So I can do else, and then I can print that they're too young. Do you see that? And only that else statement runs.
So is it okay if you have the else after the close brace property?
It is after the close brace, and it has to be here. The else statement has to be after the block of the if statement closes. Yeah.
So does this mean the else statement cannot be on a new line?
It could be on the new line, but our style guide dictates it should be on the previous line. But this will work. This will work no problem. Any other questions? Online questions? What if I'm -1 years old? That's actually a good question. What are we all thinking? Yeah, too young. But this might be an example where you want another if statement to check for invalid ages, because you can't be -1 years old. Or can you? No. Here's just an example of an else statement. We'll talk about multiple conditions right now. All right. Chaining. Oh, no, not just yet. In 2 slides. Okay. Chaining if statements. So this is useful in a lot of times where we've got ranges. So maybe I've got a VIP section for those that are 40 plus. So I want to check if you're 40 and over. I can't get in yet. 21 and 40, right? And then below 18. So multiple ranges, right? So we can chain if statements, and we do it in the exact same way we chain the else statement after the if statement. So after the first if statement block closes, we can just use another if statement. Right? So let's actually code this in. So I got my minimum age constant, and I've got this VIP minimum age constant. I read in the user's real age. I have an if statement. if you're greater than minimum, now we might actually have to change how this works. If you're greater than or equal to 21, then you're getting in. Oh, whoa. I mean, sure. If you're greater than or equal to the, what was it, VIP min age, then we can printf welcome VIP. Else, we need to put the else there. You're too, oh my God. I'm going to format the document. Else you're too young. Right? If, else. And the else will only run if both of them are false. So you're in and you're a VIP. Okay, that's a great question. What if you only want the second one to print out, not the first one? I think it's coming up in the slides, but you can do else if. So only if the first one's false, and if this thing is true, then do this. You can see that these are simple things. You were all giggling up to a second ago, but it can spiral it out in complexity pretty quickly. All right. Let's go back to our slides. All right. This is answering your question. And something else that a lot of people have asked. We're asking single questions here. If age is greater than 21 or you know, if age is greater than 40. But in many cases, we need to check multiple conditions are true at once. It's different from an if and an else, right? So we need a way to combine multiple true or false questions. And when we say combine, let's be really precise. What we mean here is that if I've got a true and a false question, in fact, I'm going to go to the whiteboard. So I've got a true or false question. So I got true. That's my question. So if true, we run the block, you know, else we don't. But maybe I want to ask another question. And the answer to that question is false. But an if statement or any condition always needs a single true or false answer. So we need a way to combine these two basically. And there's different ways to combine them. But the end goal is always the same, a single true or false value. So here's 3 ways we can combine them. Now, these aren't new concepts. If you've done mathematics and things before, you have seen them before. So we have and our operator for that is what? God, how the hell am I going to draw this? Oh, that wasn't bad. If I and these two values together, what's the answer?
False.
False. Who's new to this type of logic? Just one guy? Doubt it. One honest guy. A couple people, yeah. So this is sometimes called a truth table. But if we think about it, let's say to be a VIP, you need to be over 21 and you need to be over 40. That's a kind of a bad example because if you're over 40, you are over 21, but it doesn't matter. But you need to be both over 21 and over 40. Who agrees with that? So both conditions need to be true. That's and. both this and this. So this will return false. Right, that's the AND condition, the top one, the AND operator. Then we've got OR. What do you think OR might mean? One or the other. So what will this return? Yeah, true. And then we've got not. Not is a little different. If I've got not true, what will I have? And if I've got not false, what will I have? Yeah. Oh, you can really see I was in the same wavelength when I made these slides. So here's a similar program, but it's doing some extra checking. So when it's checking that someone is under 18, we're also checking that it's a correct value, so that it's greater than 0. So this is running if the age integer is greater than 0 and less than 18. They both need to be true. So that AND combines them for us into a single true value, true or false value. Then we've got an else if. All right, so when will this else if run?
Any value that's not greater than 0 or less than 18.
So give me a number.
-20.
Yeah, -20 will trigger this else if to run a check. Now, is -20 greater than 18? Someone said yeah? No, it's not. Therefore, the else block will catch that value.
So in the last thing, you have two ifs. You had if else. What's the difference between if else and if else?
When we have an else if, it's doing, we can piece it together because it happens in order. So we have a first if statement here. If that's not true, then we jump to this else. And then we have another if statement. So we only run this check if this failed. It looks like it stressed you out, that answer, but. So they're really simple constructs, but yeah. Someone's asked, why not greater than or equal to 18? Wouldn't this say 18 is invalid? Yeah, that's a good point, I think. All right. Let's go back to our demo and add in some multiple conditions. So here's a cool idea. So we have this VIP thing, but maybe VIP nights is only on certain nights. So I'm going to make a constant, a hash define, to decide whether or not it's a VIP night. So if it's 1, it's a VIP night. If it's 0, it's not a VIP night. Can you see where this is going? So in order to let someone into the VIP night, we need to check, are they old enough? And what? So how are we going to do that? What's the time? 25. Do you want 5 minutes to solve it yourselves, if you're following along? And then we'll do it together? Does that sound good? Oh, we haven't done the Kahoot yet either. So, all right, 5 minutes. Talk to your friends, do it together. I'll come around, and then we'll solve it together.
Sorry, so the VIP.
Oh, let's not do that. Let's not do that. Who wants me to come around? Anyone?
So when I, for some reason, okay, slow. So it's printing out acceptable but not VIP and unacceptable at the same time because it like reads my first if statement, I think, and then when it finds that it's not true, it goes to the else, prints that, and then also prints that.
No, it should be printing. No, it's doing the second one first because that's the order it's happening. Oh, this is mic is on. So it's doing enter the person's age 39, acceptable but not VIP. So that's also true.
Mhm.
Oh no, go back. Oh, and VIP. Is that what it said? Oh, sorry. Go back to your terminal. But not VIP. Where's unacceptable coming from?
I have else unacceptable.
Oh, sorry, that's running, and then that's running. I see.
Yeah.
So and the age is less than that. I think that needs to be an else if there, because this else is running for this if.
So do I do else here?
Yeah, or just before on the same line.
Oh, that's like
You
the
can
proper form.
no, sorry, no. Later on the same line before the if.
Just here.
Yep, space and then else.
Else, and then I do that.
No, just else, just like that.
Oh,
So
else.
only fix the. Yep. So let's think about this. If the age is greater than the minimum age and less than the VIP age, so they're allowed in but they're not VIP, then you do that.
Yep.
If that's not true, and they're greater than the minimum age, yep, then they'll be VIPs. If both of those are now false, then it's unacceptable.
Okay.
So save that and try that. It might have just been because you, yeah.
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 Okay, cool.
Yep.
Thank you.
Otherwise the else was triggering for the if before it.
Right.
Only the if before it.
Wait, what was the prompt that you were trying to get us to do before? Anyway.
The VIP night, this thing. But you've done an and statement. That's all I wanted to check.
So to do it, you'll do if age is more than minimum age and is equivalent to 1.
Yep.
Then you can enter. Otherwise, you can't. But what if you want to print 2 different messages depending on if you are?
We'll talk about that in a second. Yeah, we'll talk about that in a second. All right, everyone. So who got it? Who got it? One person? Couple people? Who ran into an issue? God, we got to do some serious icebreakers, I think. All right. What was the solution for someone who got it? Where?
So when it's checking for a VIP in your name, you put and then check if it's a VIP name.
How did you check that it was both a valid VIP age and that it was a VIP night? What did you type?
I just wrote in the name of the constant. So because VIP night is 1, that's true. And if the VIP age.
So you just did this. Yeah, that's cool. That's cool. So the cool thing about Boolean logic, that's what this is on the board, is that you're comparing 2 Booleans. Did anyone do it like this? So VIP night, what's the value of VIP night? 1. And 1 is true. So it's true and this question, which is either going to be true or false. So this is pretty good to me. And it's a VIP night. If I change VIP night to not be on, so it's not a VIP night, and they're 50 years old. Whoops. Did something go wrong there? Or just... Oh, I didn't compile it. You're right. Anyway, you get the idea. All right, Kahoot. Alrighty, 293-8386. Howard Wolowitz. Alrighty. Everyone in the room joined? Everyone online joined? ScanF win. Genshin. Do people still play Genshin? All right, ready to go? Yep, quickly.
It's with this one, right? So because this is what we were doing, and so even when my age was lesser than VIP age but greater than the age of entering, I'm still getting like a you cannot enter. Like if you look over here,
Yep.
and I choose 21.
You need, I think, an else if here. In this case.
But isn't else if only if this is false? But this won't be false if I choose like 40, right? Because my age will still be greater than min age. So like it won't even run this because
Then you want to swap them.
I want to swap the odd
and then put an else if. The else will trigger if this is false, but you want it to trigger if they're both false, which means you need if, else, if, else. So you might need to reorder them. Try that. But do the Kahoot. Quick. All right, we're starting. We need to get a live band in to play the Kahoot music. All right, week 2, lecture 1. Hopefully this is the right Kahoot. All right. Oh no, this looks like this. This doesn't look good. Why do we have a main function? Week 2, lecture 1. This is right. Yeah. Didn't we have this last week? Oh, hopefully the next question's different. I had a feeling. Yes, we knew that. We had this last week, didn't we? Oh no, it's different. It's different. I don't know why they're there. Just keep going. Very good. We knew that. Can I skip it? I can't skip it. Oh, skip. I'm skipping it. Who made these damn Kahoots? Skip. Is this new?
Yeah.
You're just lying. What? Did you do the wrong one? Oh.
No, I thought you were gonna skip, so I was just.
Oh. You fool.
Yeah, I fooled myself.
Declares and initializers. So was anyone else spam clicking apparently? Okay, well, that's what you get. Do we need to break this down? So it's worth breaking this down a little bit. Orange is correct, right? We're declaring a variable called mark and assigning a value of 100. The syntax is correct, so we're happy. Did anyone click red but like legitimately? Yeah, it's fine. So it is defining a constant, which is full marks, and it's putting the value 100 in it. But constants aren't variables. There's no memory. So you're on a technicality. Wrong there. And not many people did green. That's just the wrong syntax.
Is red wrong because it says in the question it initializes an integer?
Well, it's not a variable.
Right. Yeah. That's.
Yeah, there's no memory there. All right. We have 6 more questions. So it just looks like the previous 6 didn't save. All right. If I want to ask the user for input into my program, which function should I use? Oh, very good. Scanf, you've been paying attention. What happened? Wrong one. Too fast. Slow and steady wins a race. What is the correct format for scanning in an integer with an already declared variable called num? Yeah, very good, very good. To the 52 of you who forgot the ampersand, you can't forget the ampersand in scanf. It's just something you need to remember. All right, question 9. What is the value of the following expression? 1 over 2 multiplied by 500 in C. So it's just math. The limit does not exist. All right. You got it? You got it? Can you explain it? Wait, everyone be quiet. Everyone be quiet. Everyone be quiet. Everyone be quiet.
In order of operations, we divide 1 by 2, which is 0.5.
Can anyone hear him?
And then C rounds that down to 0. So 0 times 500 is not 250.
Let's say that again slightly. You're 100% correct. This is C. 1 is an integer. 2 is an integer. 1 divide 2 is 0.5, but it's an integer, so we lose everything after the point. So what's left?
0.
Times 500 is?
0.
Well done.
That was really good.
Oh, brutal. Well done. All right, 2 more questions. 3. Determine the value of this expression. 1 over 2.0 by 500. Very good. I like the 48 people like, oh, I'm gonna. An int divided by a double is a double. So that will be 0.5 multiplied by 500. So it's a double multiplied by an integer. So we'll get back a double, 250.0. Yep. Well done. All right, 2 more questions. We haven't covered this actually, so just get wrecked. Some of you may know it. Isn't it 2? Isn't it 2? It's 2. This is not correct. I'm pretty sure it's 2. Yeah. Does anyone want to tell me what this operator is? Modulo, what does it do? Yeah, the remainder of a division. So 5 goes into 17 3 times with 2 remainder. So I thought this would give back 2. Don't know who made these Kahoots. All right, last question. What is the value of this expression? 17 over, oh, well, I'm not going to read it. Let me see if I can figure it out. Too fast for me. Was that one correct? The modulo? Yeah, good. All right. We got to make a note to fix this Kahoot. All right, congrats, Demi, number 3, Metal, number 2, and number 1 is I love comp. Great work. Is that you? Oh, sad. Anyone in the room? Who are you? Demi, congrats. Anyone else? Someone said Thomas? Oh, I love the energy. You love comp, but I love comp, you know? Are the rest of you online? Don't know. I don't know. I reckon we got some infiltrators here. Forward any complaints to my legal department on the Kahoot. Come to my office afterwards and I'll get you a gift or something. All right. All right, well done. Okay. We have about 10 to 15 minutes left and we've got one more topic to cover. What's the question? You got the not operator. All right. Let's get some quiet. We got one more really important topic to cover today. Okay? Quiet. Repetition. So, please. So repetition is another form of control flow. So if we've got control flow as controlling the flow of our programs, we have if statements, which is branching, and we have repetition. What do you think it entails? It entails repeating ourselves. So why do we repeat ourselves? Why do we loop? Programmers, we are really, really lazy. If you're a really lazy programmer, you'll be a good programmer. We don't like repeating ourselves. So if I need to do something over and over and over, I don't want to write the code over and over and over. The whole point of programming is that we automate things. So if you think about a factory line that's automated, it does the same thing over and over and over. I can just keep saying that over and over and over. We can make computers do this boring automation for us, this repetition. Any real world examples where we do things on a loop?
Going to class.
Going to class? Yeah, it's meant to be really exciting. If you're brushing your teeth, you don't think about it in individual movements, do you? Right? You just brush your teeth. Even though there's repetition involved there. It's the same idea. There's things we want to do that require repetition. So this first point is really critical here. Repetitive tasks should not require repetitive code. In fact, I teach 1531 sometimes, software engineering fundamentals, and we talk about this in a lot more detail, but if you see repetitive code, so you're looking at a code file and there's blocks of code that look really similar, that's a sign of bad code. It's what we call a code smell, actually. But that's more for 1531. Repetitive tasks don't require repetitive code. If we know that C starts at main and executes each line in sequence, how can we control that sequence with repetition? So we've got 3 types of repetition or 3 types of loops to introduce. So this is the cousin to the if statement. In fact, who thinks they understood the if statement reasonably well? All right, I got really good news for you. The while statement is 90% an if statement. This is a great thing and an annoying thing, okay, this idea. It's a great thing because if you understood if statements, you're in a great spot. It's an annoying thing because if you didn't understand if statements, we're building upon what we know. This is what makes part of what makes programming challenging. Okay, so there's 3 types of while loops: counting loops, conditional loops, and sentinel loops. These are just different ways of using while loops, but the core idea is exactly the same. And here's the syntax. While, Boolean expression, and a block. So who thinks that looks really similar to the if statement? The only difference is instead of if, we have while. And there's some comments in this block that explain the difference and what's going on. So if this was an if statement and this was true, the block would run, right? Exact same thing happens here, except when we get to the end, we check the expression again and run the block again. And we do that ad infinitum, which is, I don't know why I went Latin there, but it just means we repeat it forever. That's it. That's a while statement. The idea being that maybe eventually that condition will be false and we will end. Simple concept. So here's an example. Here's an incredibly useful example. Probably every program I write today will be web systems that I build, AI systems that I build. I do something like this in here every single time. So this is a counting loop. It's one of the 3 types of loops that we typically need to use. It's going to do something and count up each time it does it until that count is over. So I want to do something n times. So I've got this variable called number of lines assigned the value of 5. And I've got this special, well, it's not special, it's just a normal variable called I. Anyone know what I stands for? Did someone say index? No? Well, I said it. So it stands for index. We use it often when we are counting. You'll see it appear in many, many examples of programs. But it's just convention. It's just a normal variable. Is that a question? Yeah, it is. Good catch. Don't know why that's... Yep, you never... Why didn't that save? Oh. That's weird. Okay. So let's think about it. We know, I promise you, you know everything you need to know to figure out what this program does. So we've got these two variables at 5 and 0. Here I've got a condition, right? Right now, will the condition be true or false? True? So is 0 less than 5? True. So will the block run? Yes, the block runs. This block runs. What do we print? And then this is the really important part here. What are we doing to I? We're adding 1 to it. So what's the value of I now?
1.
Is 1 less than 5?
Yep.
We do it again. I is now 2. Is 2 less than 5?
Yep.
3, 4, until
It reaches 5.
we get to 5. Is 5 less than 5? So the block ends and the loop ends. But we have now just done something repetitively. I'm going to copy this, go back to our environment here. Just don't forget the hash include. I'm going to call this one counting loops.c. Counting loops. Oh, I don't have int main here. Yep. How's that look? Better? And what do I call it? Counting loop. Oh my God. So what do we expect to see when we run this? Hey, who said 4 times? Who was it? How many times? Why 5? 0 to 4. 0, 1, 2, 3, 4. You were right that it stops at 4. This also gets a lot of people. So you might think, Jake, you told me we don't want to write a lot of code and we're lazy. It would have been less code for me to just print that 5 times. Who agrees with that statement? Yeah? But the power of this is that I can say, well, now I want you to 50 times. That would have taken you a bit longer, but I can go 5,000, 5 million, whatever. Should we do 5 million?
Yes.
So you think an error message? I don't know if it'll error. I think it's just going to keep printing. So I'm going about my business, going about my day, and my program is working extremely hard.
If you iterate more times than int is defined for in that range, will it return an error?
The question was, if I iterated more times than an int could store a value, would there be an error? The only error would be if this assignment is greater than an int. But I could just put that straight in here and it would be fine. But eventually, probably some upper bounds would be hit. Let's let that run while we go back to our slides. So that's the counting loop. Next, we have the conditional loop. And they're really similar except a conditional loop isn't counting an integer typically. So it's happening until some condition is met. There was a backstory to why this was the program used from a previous term. I'm not a gym junkie, as you can tell, but I've got some program with some variables, and every time the program runs, the loop runs, the variables change, and at some point the condition will be true or false, and the loop will end. But it's not counting by 1. This is kind of a bad example because this is counting by 5, I think, but you get the idea, hopefully. And Sentinel loops, these are probably the hardest to understand. Similar to a conditional loop. So we're looping until some condition, except we use a Sentinel flag to control whether or not we're complete. A Sentinel flag is just a variable that's usually a Boolean or a 0 or 1 integer. And when we want the loop to end, we set the value to be 1. So this is useful, just to give you a real example of why we talk about it. For example, let's say you're reading information off a disk. That's probably now an outdated example. Let's say you're reading information off, I'm going to just go with a disk. You might read the information until you've read all the information that you want to read, or until the operating system decides that that disk is no longer available, at which point it might set a Sentinel flag to be false or true. So it's like some external factor might end your loop with a Sentinel loop. And the while statement is while that loop is true or false. So that was just an introduction to repetition, to loops. The key thing there is that they are just if statements, except instead of just running once, they come back and check the condition over and over again. That's it. That's it. We've already done the demo, so please scan the lecture feedback QR code. I'll see you on Wednesday. We'll continue on. Thank you so much for coming. And if you've got any questions, catch me outside.